Hello everyone, welcome to A1 Tutor live class. Now we're going to be having physics class, and we have been taking an interesting topic since the beginning of this week, which is a machine, or let me say simple machine. We've taken the first part and we've taken the second part. Today we are taking the concluding part, which is part 3, simple machine or machine part 3. Today mostly we'll be focused on calculations, how to calculate the efficiency of a machine, how to calculate the mechanical advantage, and the velocity ratio of a machine. That is what we are going to consider today. In our previous class, we've discussed what a machine is. We've discussed what a machine is and also the types of machine that we have. We considered like 8 types of machine: the lever, the pulley system, the wedge, the hydraulic press or jack, the screw jack, the inclined plane. All these were the types of machine that we discussed in our previous class. So in case you had not chance to join us for those 2 classes that we've had earlier, you can do well to watch the video on YouTube, search for A1 Tutor, and search for the topic simple machine. Simple machine. You're going to have the list of the videos we've done on simple machine. And for you to have updates frequently, anytime we upload our video, you just need to subscribe on the YouTube channel, press the subscribe button, and also you can click on the notification bell so you have access to our video as we upload it. You'll be getting notifications anytime we upload our videos, so you won't miss any of the classes. Do well to what? To click on the notification bells so you can have updates of our videos as we post them on the YouTube channel. So today, like we said, we'll be focusing the more on calculation aspect of machine, and we are going to be dealing with some UTME questions that we have on grant. We are going to be solving different UTME questions that has to do with simple machine or machine. All right, so to start, we'll be talking about machine efficiency, and machine efficiency has to do with the symbol. Efficiency has to do with the mechanical advantage over the velocity ratio multiplied by 100, where mechanical advantage is equals to the load over effort. The load over effort, and the velocity ratio is equals to the work output over the work input, where the velocity ratio equals to the work output over the work input. So today we'll be using these formulas to actually do some calculation. We said velocity ratio is the distance moved by effort, the distance moved by effort, which is also the work output over the distance moved by the load, the distance moved by the load, which is also over the work input, So we are going to be using these formulas to solve questions in simple machine. We're going to consider how to obtain the efficiency of a machine, the mechanical advantage of a machine, and also the velocity ratio of a machine. If you are with me, please kindly signify, as we are going to start with the first question. They are all UTME questions, and we are going to solve them together. If you are with me, please kindly signify as we proceed to the calculation aspect of simple machine. All right, thanks for your response, Abiodun. Now let's proceed to the calculation aspect. So what we are considering is calculation on simple machine. Calculation on simple machine. Now let's go for the first question that we're going to be solving today. The first question is a UTME question. The first question is a UTME question 2002. 2002. What are we asked to solve? We are asked to find UTME question 2002. A block and a tackle system has 6 pullings. A force of 50 Newton applied to lift a load of weight W if the efficiency of the system is 40%. Calculate W. So we expect it to calculate the value of W. The value of W. Now from the question, we have a block and tackle system has 6 pulling system. So this question is talking about the type of machine called the pulling system. Called the pulling system. It's talking about the type of machine called the pulling system. So the question says the system has 6 pulling. So numbers of pulling is what? 6. Numbers of pulling is 6. What is a pulling? Let's say we have a system of pulling and we have this are called pulling where you'll be attaching your rope to. So in this case, we have 1, 2, 3, that's 3 pullings. But for this question given unto us, the question stated that we have 6 pulling. We have 6 pulling. So we've written that we have 6 pulling and a force of 50 Newton applied to lift a load. That means the effort was given to be 50 Newton. The force applied to lift the load is 50 Newton. The force applied to lift the load is 50 Newton. So the effort is 50 Newton. If the efficiency of the system is 40%, efficiency with this symbol is 40%. We are trying to write out the parameters so we know how to go about the solution. So we are asked to calculate the value of W. What is the value of W? The value of W is the load, the weight of the load. The weight of the load is what? W. So W equals to what? Load, which is unknown. The value is unknown. So we have to solve to get the value of W, which is the load. The load and the effort are always measured in Newton. The load and the effort are always measured in Newton. Take note of that. The load and the effort are always measured in Newton. So to solve this, we are given the pulling, and the number of pulling we have in a pulley system is equals to the velocity ratio. Is equals to the velocity ratio, which implies that we have 6 numbers of pulling. That implies that the velocity ratio for this pulling system is 6. The velocity ratio is 6. So if efficiency is equals to mechanical advantage over the velocity ratio multiplied by 100, where mechanical advantage equals to the load over effort, and the velocity ratio is already given to be 6. The velocity ratio is already given to be 6. And we are also given the efficiency. The efficiency is given to be 40%. So I can substitute that into the formula. I will say we have 40%, which is also 40, equals to the mechanical advantage. The mechanical advantage is load over effort. And effort has been given to be 50 Newton. So that means we have mechanical advantage, which is load over effort, okay, divided by the velocity ratio, close the bracket, everything is multiplied by 100. Everything is multiplied by 100. That is 40% equals to, open the bracket, the load is not given, the load is taken to be W, the load is taken to be W. So we have W over the effort, which is 50, divided by the velocity ratio, which is 6, close the bracket, multiplied by 100. So that is going to give us 40 equals to W over 50. Changing the division sign to multiplication, we have times 1 over 6, close the bracket, times 100%. We'll proceed to solve this. We have 40 equals to 1 multiplied by W is W over 50 multiplied by 6. 50 multiplied by 6 is 300. 50 multiplied by 6 is 300. 50 multiplied by 6, 50 multiplied by 6, 300. 300 multiplied by the 100 we have here. So we have 0 can cancel 0 out. 0 cancels 0, and 0 we cancel 0. We are left with the value 40 equals to W over 3. By cross multiplication, we have 1 multiplied by W, 1 multiplied by W equals to 40 multiplied by 3. 1 multiplied by W is W equals to 40 times 3 is 120. So W, which represents the load, is 120 Newton. Is 120 Newton. So the load for this question, which is W, is calculated to be 120 Newton. 120 Newton. If this first question is clear to us, please kindly signify as we are going to take the second question. Thumbs up by give your reaction if the first question is clear to you. Signify with a thumbs up. If the first question is clear to you, signify with a thumbs up. Waiting for your reaction as we'll be taking the second question. If the first question is clear to us, please kindly signify with a thumbs up. And let's move to the next question. Okay. Can we proceed to the second question now? If yes, permit me to wipe the board. So we take the second question. The second question now. Question number 2, still solving question on the machine. We'll pick this next question. The next question is a UTME question, 1983. 1983. UTME question 9083. So we have the next question, UTME 9083. A machine has a velocity ratio of 5. It requires a 50 kilogram weight to overcome a 20 kilogram weight. The efficiency is dash. We are asked to calculate the efficiency of that question. In the question, we are given the velocity ratio, VR, the velocity ratio, VR, to be 6, the velocity ratio to be 6, and we are given it requires a 50 kilogram weight to overcome a 200 kg weight, which implies that the load we want to overcome, the load is 200 kg, and the effort required to overcome that is 50 kg. All right, the load is 200 kg, while the effort is 50 kg. So we have mechanical advantage to be equals to the load over the effort, which is 200 over 50, 0 cancels 0, that is 20 over 5, and that will give us 4. The mechanical advantage is calculated to be 4. What is now the efficiency? Efficiency is mechanical advantage over the velocity ratio multiplied by 100, which is equals to 4 over 6 multiplied by 100. 4 over 6 multiplied by 100. 4 multiplied by 100 is 400 all over 6. So by division, dividing 400 by 6, dividing 400 by 6, dividing 400 by 6, we're going to have 133.333. Can that be the correct answer? Of course, no. The percentage have to be 100. The percentage have to be 100. It must not exceed 100. The percentage must not exceed 100. So we need to check our solution. Okay, I can see where the error came from. The velocity ratio is 5, not 6. Velocity ratio is 5. So we have to correct that. This is 5. So if you have that as 5, then we can go ahead to solve again. Velocity ratio is 5, not 6. From the question, the velocity ratio is 5. So we have 4 over 5 multiplied by 100. That is 400 over 5, which is going to give us 80%, which is going to give us 80%. Take note, anytime you are calculating for efficiency, your answer must be less than 0. Your answer must be less than 100%. Sorry, your answer must be less than 100%, because a machine cannot attain 100% efficiency because of frictional force. Because of frictional force, a machine cannot obtain 100%. So if a machine cannot obtain 100%, that means efficiency should not be greater than 100. It should be less than 100. So you can have 80%, 45%, 75%, and so on and so forth. Okay, so that's the way you're going to know whether you are right or not. When you are solving for the efficiency, your answer should be within the range of 1% to 99%. Within that range, your answer should be within the range of 1% to 99%. Because no machine can attain 100%. because of the presence of frictional force. Because of the presence of frictional force. So the efficiency of this question, as we have calculated, is 80%. The efficiency is 80%. If this is clear to us, let's signify as we are moving on to the next question, which is question number 3. If this is clear to us, please signify by thumbs up, by giving a thumbs up. If this question is clear to us, signify by giving a thumbs up. We are moving on to question 3. I'll be expecting our reactions. Permit me to wipe the board as we take the next question. The next question, that's question 3. We'll take another UTME question again. Now we'll be considering UTME question 1984. 1984. So the question we'll be considering is a UTME question from the year 1984. 1984. What are we asked to do? Let's check the question together. UTME question 1984. The plane inclined at an angle of 30 degrees to the horizontal has an efficiency of 60%. The force parallel to the plane required to push a load of 120 Newton uniformly up the place is dashed. So what we are asked to calculate here is to calculate the efforts. The effort needed in this expression is what we are asked to calculate. In the question, we are given value of theta to be 30 degrees. That's the angle formed by the inclined machine. The angle formed by the inclined machine. We talked about inclined machine also. So this theta here is what? 30 degrees. Okay, theta equals to 30 degrees. And again, we are given the efficiency of the machine to be 60%. 60%. The force parallel to the plane required to push the load, capital letter L is 120 Newton, and we are asked to get the force. The force, which is also the effort, is question mark. We are asked to obtain the force, which is also known as the effort in lifting or pushing the 120 Newton load. The effort required in pushing the 120 Newton load. All right. So efficiency is still the same thing as efficiency is given as the mechanical advantage over the velocity ratio multiplied by 100. How do we get the velocity ratio? Velocity ratio equals to 1 over sine theta for an inclined machine. For an inclined plane machine, the velocity ratio is equal to 1 over sine theta, and that is 1 over sine 30 degree, 1 over sine 30 degree. And when you evaluate that, 1 over sine 30 degree will give us 2. 1 over sine 30 degree is 2. That is, the velocity ratio is 2. And the mechanical advantage, MA, is equals to the load over the effort, or let's call it the force. The load is 120, while the effort is unknown. So we need to substitute all this inside the formula that we are given. Efficiency equals to mechanical advantage over the velocity ratio. So we have efficiency to be 60% equals to mechanical advantage, which is 120 over E divided by the velocity ratio, which is 2, close the bracket, times 100. So what you have just done is this expression, MA over VR. So 120 over E represents MA, then 2 represents the velocity ratio. 60% equals to 120 over E, changing division to multiplication, we have times 1 over 2 times 100 over 1. By cancelling zeros, do we have any zeros we can cancel? No, but 2 here is 1, 2 here is 50. So we have the next line to be 60 equals to 120 times 1 times 50 all over E multiplied by 1 multiplied by 1, which is 60 equals to 120 multiplied by 50, 120 multiplied by 50, 120 multiplied by 50 will give us 6,000. So we have 6,000 divided by E. If this 60 is expressed as over 1, by cross multiplication, we have 60E equals to 6,000. And to get the effort, which is E, to get the value of the effort, which is E, we are going to divide both sides by 60. That's 60E over 60 is equals to 6,000 over 60. So we have 60, we cancel out 60. 60 cancel out 60. E equals to 0 cancel 0. 600 divided by 6 is 100. So the effort is 100 Newton. The effort is 100 Newton. The effort for this question is 100 Newton. I believe this is clear to us. If yes, please kindly signify. We are moving on to the next question, to the next UTME question. Today we are specifically solving UTME question on simple machine, UTME question on simple machine. And we have been considering the efficiency of a machine, the mechanical advantage of a machine, and the velocity ratio of a machine. So if this question that we just solved is clear to us, please kindly thumbs up, and let's move on to the next question. Let's move on to the next question. That will be question number 4. Can we proceed to the next question? If yes, signify, and let's move on to the next. Okay, thanks for your response. Let's move on to the next. But before that, let's take a pause. Please, if this is the first time that you are coming across our video on YouTube, please do well to subscribe to our YouTube channel. Do well to subscribe to our YouTube channel. Click the subscription button, click on it, and you will get notifications anytime we upload our videos. Do well to recommend our YouTube channels also to your friends in school so they can also benefit from these lessons and from these videos. And also, they'll be able to learn smarter as we have been learning. Okay? Now, let's take the next question, which is question number 4. Question number 4. Permit me to wipe the board. Question 4. Consider a next question, which is question 4. UTME question 1986. 1986. Want to consider that this question, UTME question 1986. Okay, so we have to solve this question, UTME question 1986. A pooling system with 6 pooling on which an effort of W Newton supports a load of 120 Newton. If the efficiency of the machine is 40%, then the value of W is dash. We are given the numbers of pooling. We have 6 pooling. So we have number of pooling equals to 6, on which an effort of W Newton. So my effort was given as W, support a load of 120. The effort is W, and the load L is 120 Newton. If the efficiency of the machine efficiency is 40%, what is the value of W? What is the value of W? How do we get that? We still make use of the formula for efficiency, which is efficiency equals to mechanical advantage over velocity ratio, where the mechanical advantage equals to the load over effort, and the load is given as 120, and the effort is given as W. And for the velocity ratio is the numbers of pooling. In a pooling system, your velocity ratio is the number of pooling. The number of pooling is 6. That implies that the velocity ratio is also 6. So we have efficiency equals to mechanical advantage over velocity ratio. Substituting the value, efficiency is 40 equals to the mechanical advantage is 120 over W, open the bracket, 120 over W divided by velocity ratio divided by 6, which is the velocity ratio, multiplied by 100. So we have 40% equals to 120 over W, changing division sign to multiplication, times 1 over 6. That is, there's going to be a reciprocation immediately after the division sign has changed to multiplication. Then we have times 100 times 100. 40% equals to 120 times 100 all over 6 times W is 6W. It is 6W. So by cross multiplication, we have 40 times 6W equals to 120 times 100, which is equals to this 40 times 6W is 240W equals to 1,000. Equals to 12,000, dividing both sides by W, we are going to have W equals to 12,000 divided by 240. 12,000 divided by 240. If 0 cancel out 0, we have 1,200 divided by 24, and we need to simplify that. We are trying to get the value for W, which represents the effort. So 1,200 divided by 24, 1,200 divided by 24 is 600. 600 Newton. Take note, I said that load and effort in this topic are measured in Newton. They are measured in Newton. So if you are done with this calculation and you do not add Newton to your answer, that means you are actually closer to the answer, but not yet correct. Okay, so we need to add Newton to the answer. So the load is 600 Newton. The load is 600 Newton. If this is clear to us, please kindly signify as we move on to question number 5 of UTME. We are moving on to question number 5 of UTME. If this is clear to you, please signify by thumbs up. Signify by thumbs up. So we'll move on to the next question, which is question number 5. Signify if this is clear to you. Okay, I'm waiting for your reactions so that we can dive into the next. And we'll proceed to the next question, which is going to be question number 5. Okay, we should proceed, right? Okay, thanks for that. So we are going to wipe the board and take the next question, question number 5. Question number 5. Let's check the next UTME question we'll be taking. That's UTME question 1991. UTME question 1991. UTME question 1991. That will be the next question we'll be considering. UTME question 1991. We have this question to solve in the UTME question 1991. Now, this question has to do with the wheel and axis. Is another type of machine. Another type of machine is the wheel and the axis. So here we have the velocity ratio under wheel and axis. Under the wheel and axis as a type of machine, the velocity ratio is given as capital letter R over small letter r, where capital letter R represents the radius of the wheel and small letter r represents the radius of the axis. So this is for the wheel, while this is the radius for the axis. So the radius is going to be used to obtain the velocity ratio. So in the question, we have a wheel and axis has a radii, 80 centimeter and 10 centimeter. If the efficiency of the machine is 85% and the force applied the force of 120 of 1,200 Newton to the wheel will raise the load dash. So what we want to find here is to get the load, the magnitude of the load. So we are given the radii for both the wheel and the axis, So we have capital letter R is 80 centimeter, small letter r is 10 centimeter, and that is the velocity ratio is capital letter R over small letter r, which is 80 over 10, and that is 8. So the velocity ratio is 8. The velocity ratio is 8. And we are given efficiency in the question. Efficiency is 85%. Efficiency is 85%. And also applied a force of 1,200 Newton to the wheel. So the effort or the force applied is 1,200 Newton. So we are asked to get the load. What will be the load? Question mark. We do not know the value of the load, so we are going to solve for the load using the formula of efficiency. Using the formula of efficiency. Efficiency equals to mechanical advantage over velocity ratio multiplied by 100, where efficiency is given to be 85 equals to mechanical advantage. Mechanical advantage is given as load over effort, load over effort divided by the velocity ratio, which is 8, multiplied by 100. So we have 85 equals to, the load is not given, so we have N, but the effort was given to be 1,200 multiplied by, changing this to multiplication, we are going to have 1 over 8, 1 over 8, then times 100 over 1. 85 equals to load, which is L times 1 times 100, that is 100L over 1,200 multiplied by 8, 1,200 multiplied by 8. 1,200 multiplied by 8, we have 9,600. So 85 equals to 1,000 L or 100L over 9,600 rather, over 1. By cross multiplication, we are going to have 100L equals to 9,600 times 85, which L will now be equals to 9,600 multiplied by 85 divided by the coefficient of L, which is 100. So we have 0 to cancel 0 and 0 to cancel 0. L is now equals to 96 times 85. We have to multiply that. 96 times 85. 96 multiplied by 85. We're going to have it as 8,160 Newton. So the load is 8,160 Newton. The load is 8,160 Newton. I believe this is clear to us. If yes, signify. We are taking the next question, which will be question number 6. Another UTME question again. If it is clear, please kindly signify by thumbs up. Kindly signify by thumbs up as we move to the next question, which is question number 6. Question number 6. Okay, thanks for your response. Let's move on to the next question. Question number 6. I'll wipe the board. I'm going to wipe the board so we can take the next question. That's question number 6. Question number 6. Question number 6 will be another UTME question, and that is UTME question 2001. 2001. 2001. We have this question to solve. UTME question 2001. 2001. Question. A wheel and axle. So we are still working under axles and wheel. Axles and wheel. So that is to say the velocity ratio will still remain capital letter R over small letter r. Take note of that. Under the type of machine, axis and wheel. The velocity ratio is capital letter R over small letter r. So we have in the question, is used to raise a load of 500 Newton. Load, capital letter L, is 500 Newton by the application of an effort of 250 Newton. Effort equals to 250 Newton. Effort equals to 250 Newton. Now we are asked to calculate the efficiency of the machine when we are given the radius to be capital letter R 0.4 centimeter, small letter r 0.1 centimeter. Efficiency for this machine is the mechanical advantage over the velocity ratio multiplied by 100. Mechanical advantage over velocity ratio multiplied by 100. Efficiency equals to the mechanical advantage is load over effort divided by the velocity ratio is capital letter R over small letter r multiplied by 100. Efficiency equals to the load is 500 Newton and the effort is 250 Newton divided by 0.4 over 0.1 multiplied by 100. Efficiency will be equals to 500 over 250 multiplied by, there will be a reciprocation, and 0.4 over 0.1 will now be 0.1 over 0.4 times 100. Okay, so we're going to multiply this out. We're going to have the efficiency to be equals to 500 times 0.1 times 100 all over 250 times 0.4. Efficiency equals to multiplying 500 by 0.1, 500 multiplied by 0.1 multiplied by 100. We have 5,000 divided by 250 multiplied by 0.4, 250 multiplied by 0.4, that is 100. If 0 cancels 0, 0 cancels 0, efficiency equals to 50%. Efficiency equals to 50%. So the efficiency of this question is 50%. The efficiency of the machine is 50%. Okay, I believe that is clear. So this is the sixth question we've solved on UTME based on efficiency of a machine in UTME questions. Okay, so if you have questions, please kindly do well to drop your questions in the comment section. And for our followers on YouTube, if you have any questions, our followers on YouTube, if you have any questions based on this topic or based on the questions we solve, please drop your question in the comment section on YouTube. Drop your question in the comment section on YouTube. And do not forget to kindly subscribe to the YouTube channel and also click on the notification bell. Click on the notification bell or the notification button so you can have updates of our videos as we upload them on daily basis. Okay? All right, now let's move on to the next question. We've taken question number 6. Now we're going to take question number 7 on UTME question again. Still solving question on UTME. If you are done, you can kindly screenshot this page and let's proceed to the next. I'm going to wipe the board so we can take the next question, which is question number 7. Question number 7. Okay, so we're going to wipe the board and take the next question. Question 7. Question 7 will be another UTME question, and that will be question number 7. UTME question 2004. UTME question 2004. UTME question 2004. UTME question 2004. So this is the next question we'll be taking. Question number 4. UTME question 2004. In a hydraulic press is another type of machine or another type of super machine. We have discussed that in the previous class. We discussed the type of machine, and we also treated the hydraulic press, which is also a type of machine. So let's see how we can also have a calculation being done on hydraulic press. Hydraulic press, a force of 4 Newton is applied to the effort piston. A force of 40 Newton, a force of 40 Newton is applied to the piston area. So we have A1 representing the piston area 0.4, 0.4. And also we have, if the force exerted on the load piston is 400 Newton, the force exerted on the load is 400 Newton. If the force exerted on the load piston is 400 Newton, take note, this is our load. Our load is given to be 40 Newton, while the force exerted on the load is 400 Newton. We are asked to find the area of the piston. That is the larger area of the piston. Let's take that as what? A2, and that is unknown. Here we have mechanical advantage will be equals to load over effort, which we are going to equivalent it to, we are going to have it as equivalent to the area of the load, A1 over A2, where the load has been given to be 40 and the effort is 400, equals to the area here is 0.4 and A2, which is the larger area, is unknown. So by cross multiplication, we have 40 A2 equals to 400 times 0.4. 40 A2 equals to 400 times 0.4, 400 multiplied by 0.4, 400 multiplied by 0.4 is 160. 160. Dividing both sides by 40, we have 160 divided by 40. 0 cancels 0. A2 equals to 16 divided by 4, which is A2, the area of the larger piston, to be equals to 4. So the area of the larger piston is 4 meters squared. The area of the larger piston is 4 meters squared. The area of the larger piston is 4 meters squared. So that's what we are asked to find. We are asked to obtain the area of the larger piston. Is this clear to us? If yes, please let's kindly signify. We'll be stopping here today, and we've come to the end of the topic simple machine. We had part 1, part 2, part 3. Today, the one we had today is part 3, and that is the concluding part of simple machine as a topic. Next class, we are going to take a new topic that is under the JAMB syllabus. So we have come to the end of simple machine as a topic. So perhaps you have missed any of the classes for simple machine. Just do not panic. Go to the YouTube channel, search for A1 Tutor, and you will have the list of all the videos you uploaded. There you are going to find machine part 1, machine part 2, and you can watch and learn smarter. Is there any question? If there are questions, do well to drop your question in the chat box or in the comment section. That's for our followers on YouTube. If you have any question, you have anything you want to say concerning our content, just drop your comments in the comment section. Okay, so please do not forget that practice makes perfection, and I will urge us to always practice more and more by using the A1 Tutor app. Make use of the CBT session, practice questions on machine, so you can be familiar with the calculations and you are going to ace your JAMB score this year. Tell your friends also to join the winning team. This live session is free. The app is free. The videos you are watching on the app is free. The past questions are free. The explanations are free. So everything comes with no cost. All of these at no cost. So do well to tell your friends to join us, share the app with them, or ask them to download the app on Apple Store or on Android or Google Play Store. Download the app and join the live class. The live class continues tomorrow. Ensure you make yourself available. Do not forget, subscribe on our YouTube channel. Thank you, and thank you for your time. We are going to meet tomorrow again. Bye.